Hello friends and welcome back to the channel. Today we will discuss a simple problem on BJT where we have to find where the transistor is biased at, that is IC, the current flowing through the transistor, and the voltage V as indicated here. So let's start. The information given in the question is the input applied at base is 2.7 volts and the VCC is 10 volts. The value of RC is 2.5 kilo ohms. Beta is given as 100 and the transistor is silicon transistor. So the first important conclusion which we get from this is that silicon transistor indicates the value of VBE will be 0.7 volts. Now to find the value of IC, first we will apply KVL at the input side, that is the base emitter loop. Now when we start from here, we'll get 2.7 minus the current flowing through this 40 kilo ohm resistor will be IB. So IB, and here we'll get a drop of plus minus 0.7 volt, that is VBE. Now when we write the KVL equation in this loop, we get the equation as 2.7 minus IB into 40K minus 0.7 equals to 0. Now after calculating the value of IB, we get 0.05 milliampere. Friends, at this stage we don't know where the transistor is biased in, so by default we assume that the transistor is working in active region. Now when we know the important formula, that is IC is equals to beta IB. After applying this formula, we get the value of IC, that is 5 milliampere. Now if we apply the KVL in the outer loop, that is starting from VCC to the ground with VCE, we get 10 minus 5, that is the IC flowing through this, into 2.5 is equals to minus 2.5 volts. Friends, what the conclusion is, can the drop across RC be negative? Can you guess why? The simple answer to this question is no. The drop across the RC, no, the drop across the RC cannot be negative. Why? Because in NPN transistor the current flows from VCC, that is the IC, downwards, not upwards. So this violates the basic law and that's why it cannot be negative. So friends, the conclusion from this value is that our assumption that the transistor was in active region is wrong. Now what we will assume, some of the conclusions from this is that the transistor is not biased in active region and transistor has non-zero positive input, which indicates that transistor is not in cutoff region also. So the remaining situation is transistor should be biased in saturation region. Now when the transistor is biased in saturation region, we know that the drop across, that is VCE, is 0.2 volts. Now applying the KVL equation in the outer loop, we get VCC minus ICRC minus VCE is equals to 0. Now substituting the values here, we get the value of IC is equals to 3.9 milliamperes. So the transistor is biased at 3.9 milliamperes. Now can you find the value of V, friends? Yes, you can. How you can find the value of V? Now we know that the transistor's IC current, that is the collector current, is 3.9 milliamperes. Now what you have to do is just multiply this with 3.5 and calculate the drop. Whatever the value of that V will be is your answer. So friends, I hope you can calculate the value of V now. Thank you. Hope you have gained some concepts today.